Thanks, Antonio, for the introduction. And I will today describe the optical coherence tomography and what we can provide for this standard technique. Let me say, we see more advanced before in the presentation. Let me introduce quickly Hamamatsu Photonics. We are a Japanese company. It was founded 70 years ago, more than 70 years ago. We have many numbers here, but I want to highlight in particular how many products we are able to provide. We are basically a world leader in manufacturing optoelectronics module, components, module, and system. We have more than 50,000 products that are not only detector but also emitters, and more than 2 parts of 3, so around 10,000 products are customized solution. We are able not only to support our customer in the implementation and use of our components or module or system, but also to customize the solution to help the integration or the use of the product. In this context, I want also to highlight our new pilot line that was announced during the different event that we have in Europe, the Technology Day. I think that your colleagues was joining in this, and we will have also the next one in Barcelona in June. And basically, we are expert in the components. We are expert in making prototype for the component and the optimization of the design of this prototype for creating a new product, basically. With this pilot line, we want to help all our customers that have an idea, or new customers that have an idea, with our expertise. So the idea is basically to collect all the possible idea for new product or new also business development, or what are all the idea that you have for the use of photonics. What we can offer our expertise in terms of the feasibility, so we can evaluate the feasibility of the idea, we can provide feedback about it, and also in case it's good feedback and feasible, also the design for it. What we don't include for sure, it's the realization of the prototypes. So in case of energy cost or something, it's something that we need to discuss with the proposal idea. But we are also in collaboration with PhotonHub for this. PhotonHub was also mentioned before at the starting from Antonio. It's one, basically, they received the mandatory from European Commission to promote the new photonics idea and developments in Europe, and they can also support this new idea with some money that they receive from the Europe. So in these terms of collaboration, we can also work together in order to create your new model of the business or your idea. This is more or less the idea of the pilot line. So don't hesitate to contact us. Here there are the address. You can just write your idea and or asking to fix a call in order to discuss it and see how it works. Okay, let's move now to the real topic of today. So optical coherence tomography, it's a technique very famous, but very quickly, just to remind to everyone, thanks to these techniques allow to study the condition of our eye. In particular, basically, he studied the recombination of the interference figure and the reference beam that it's collected from the eye, basically along the zeta axis. By a Fourier transform, we can catch the signal. In case we combine this with the movement on the horizontal axis, we can obtain the topography of all the eye. There are two main optical coherence tomography, depends from the light source that we are using. There are the swept source. In this case, basically, we use a light source that send each wavelength one per one in the sample. And usually the detector that are used to collect the signal are the balance detector, because they can reach the reference beam and the interference figure that it's created from the analysis of the sample, from the reflection. or the spectral domain. In this case, we can use a broadband light source, and we can resolve each wavelengths by the use of gratings. Today, I want to focalize our attention in particular on this second one, so on the spectral domain, OCT. Why it's so important was also mentioned a little bit from Maria in the starting of the presentation. Today, we are starting to have an issue with the myopia in the future. It's estimated that in 2050, the half of the population will be issues with the eye, and 1 part of 10 of these maybe will have a strong myopia. The risk is also to losing the eye things. This due to the change of the routine, the use of mirrors, smartphone, and also to stay more indoors. So this is something that we need to take care and consider. And the spectral domain OCT is a very good and powerful technique to study and the health of the eye, and to also check the checkup and regularity checking of our health, in particular for this part. This is the more in details, the scheme that I showed before. So we have a broadband wavelength light source. The beam is split basically in the reference part and in the beam that arrive to the sample, so to the eye. How to address this usually can be used the mirror before then all the new methods that was showed before from the other talker. And the signal, the interference signal that it's created from the analysis of the eye come back to the image sensor by a grating. In Hamamatsu, we offer components. Basically, we can offer all this type of components, the light source, but today I will not speak about the light source, but more about the linear image sensor and the MEMS mirror. As I mentioned, it's very important to the checkup, the regularity checkup. And today, one of the issues is the accessibility of this instrument, because today the instruments are very big and very expensive, so usually are not present everywhere in the world. In particular, if we think in some area that maybe doesn't have a hospital or very, very far from the hospital. Now, one of the main trends in medical is to use MEMS mirror instead of the Galvano mirror. In this way, basically MEMS mirror are more smaller in terms of complete overall dimension, and can be used one mirror for the both axes in order to map all the eye. And this is an advantage not only in terms of cost for sure, but also in terms of the complete dimension of the instrument. So from the today instrument, we are moving in very small instruments that are also cheaper. And this helps to have more instruments available, not only the big hospital, but also more close to the people that need to make checkup and regular checkup and checking it. And these also have an impact on this have an impact also the dimension and performance of the image sensor that are more smaller with high performance. In terms of the sensor that in Hamamatsu we can offer for this technique, I want to mention it in particular the standard sensor like CCD and CMOS. We offer not only the sensor but also module that easily integrate this sensor with an easy communication. So we already provide the electronics to drive the sensor and to catch out the signal. We are able to offer also in-gas sensor in case we want to use more infrared detection, and the balance detector that are usually used for the SS OCT. What are offering new compared to the linear lineup of our product? For the sensor, basically, we are working on this new sensor module that will be available soon that integrate our CMOS. The sensor inside have a dimension of the pixel of 7 micro for 200 micro with 1000 pixel, with a high-speed readout and a mobile industry process interface. This module can be provided with the anti-reflection coating or without the window. But we are also working on a new sensor that it's basically included in this module that will be released soon. This new sensor will have basically the double of the pixel compared to the existing one, but will able also to provide the double of the speed readout. So we are able to arrive to 61 kilohertz. There is also another advantage in this new sensor. We are able to provide the function called 2-pixel binning function that basically allows to increase the pixel readout with the reduction of the pixel. If you don't need 2000 pixel, but you can use 1000 pixel, basically you can reach a readout of 100 kilohertz. This module will have the electronics to drive the new sensor and also the possibility to be connected by an USB 3.2, so it's very easy to connect. In terms of the MEMS mirror, actually we are able to provide these three MEMS, in particular the resonant on 2 axes or the linear on 2 axes. But what I want to show today to you, it's also this new MEMS mirror that will be available soon. This month, honestly, in June, so very, very soon. And what we are realizing here, we increase the mirror size, so we arrive to 5 millimeters with the usual optical deflection angle that is plus minus 10 degrees on both axes, with a good frequency, 100 hertz for the primary axis and 50 hertz for the second axis. So, in conclusion, thank you for listening. And again, here this is my email if you want to have more information about this new product. And here the email of the pilot line that I try to describe you at the starting. So, thank you for listening.